So following on from the previous video, we were trying to work out the surface area, and we got to this stage here where we wanted to know the surface area, and it boils down to us trying to work out this integral here. And the way we would do that is for us to zoom into this bit here, create a triangle in such a way that this is true. So if you make this to be 2x and this to be 1, then you can make all these substitutions here. So we can put this into this complicated square root thing here, and then we can put dx. We can put this into the dx here, and then from here that will then take us to here. That will then take us to here. But then we still need to replace this x squared. So we would go back to this bit here, and then divide both sides by 2. So that would give us this. But because we're after x squared, we're after this x squared here, then we would square both sides. So that would then give us this tan squared theta over 4. So we would then put it into here. So that would then take us to here. That would then take us to here. Okay. So now it's just a matter of tidying this up. So this times with this, so that would then give you to the power of 3, and then this 2 will cancel out with this, factor out this, that will then give you this. So now it boils down to us trying to integrate this. Now to integrate this, whenever you see tan theta, whenever you see tan squared theta, think about this. When you differentiate tan, because this is in effect tan, when you differentiate tan, we've done this many times. When you differentiate tan, you will get you will get this or this. Well, don't forget this is secant squared of x. So when you differentiate, hang on, let's go back one step. When you're trying to integrate something like this that involves tan squared, think about this. Think about this. When you differentiate tan, it would give you this or this. Now, when you differentiate tan, it will give you this or this. That means that you can say that this is exactly the same as this. Okay, the two are equal. Now we want to replace tan squared, so take away 1 from both sides. So tan squared is really secant squared take away 1. So we can put that into this tan squared here. So earlier we were here. Now tan squared, well, take away 1 from both sides, that will then give you this tan squared x secant blah blah. We can now put this into the tan squared here. Okay, so that will then take us to this. Now multiply this out. So that will then give us this. Now well, I did require you to know that I did require you to know how to integrate this and this, and I've done 2 videos on this already. So maybe track back to one of the early videos, or 2 of the early videos. Well, anyway, to integrate this, it will then give you. Hang on, let me think about this. So when you're here, think about this. Integrate this separately. So think about this: secant to the power of 5 theta, and then d theta, and then take away. Yeah. So think about think about doing the 2 separately. Well, integrate this. It will then give you this whole thing here, and then integrate this. It will then give you this whole thing here. Don't forget you've got your pi over 4 here as well. So that's this pi over 4, and well, integrate this and this. It will then take you to this stage here. But the thing is, we don't want the answer in terms of theta. And then in the previous video, we said let 2x be tan theta. So we don't want the answer in terms of theta. So now from here, inverse tan equally to both sides. So theta equals this thing here. So now we've got to put this thing back into the theta here, because we don't want the answer in terms of theta. And then tan theta is a neat and tidy 2x. So we can put it into here. And then don't forget you've got to put this thing. Don't forget you've got to put this thing into the theta here. and this tan theta here is a nice neat 2x, and so on. You've got to do it with all these here. Well, if you put this into the theta here, this bit here is really messy because you've got secant of the angle. You've got secant of the angle, which is tan inverse tan 2x, and then you've got to the power here of 3, to the power of 3 here. So whenever you have a trig acting on another trig, tidy it up. So here we've got a scenario where we've got a trig acting on a trig. Whenever you have a trig acting on a trig, so hang on. So let me start from here again. So we're going to put this theta equals this. We're going to put this into here. Okay, so then this whole thing here will then become this. Will then become this. Okay, and then there are other parts here, but I'm just going to leave these other parts and just show you how to tidy this up. Once you know how to do this, then you can tidy up all the other parts. So I'm going to show you how to tidy this bit up. Once you know how to do this bit, then you can tidy up all these ones as well. Okay, so let's look at this. When this is tan, this is theta. Put theta into here, and then this thing here will then become this bit here. Will then become this bit here. Don't forget this this tan theta here. So remember, we are just looking at this bit here. I'm forgetting about these lot. So this tan here, this block of tan here, is right here. Okay, and then this whole thing here would then be this bit here. Would then be this bit here. Now we need to translate this because you've got a trig acting on a trig. So now look at your triangle. If you try and translate this, what this means is, well, inverse tan. Well, tan is this thing here. Tan is this thing here. So when you inverse 2x over 1, then when you inverse tan 2x over 1, this whole block here collectively is the angle. It represents the angle, because if you inverse this divided by this, then this block here is the angle. So hang on, let's start again. Tan is given by 2x over 1. But when you inverse this, then this whole thing here is the angle. So you got to imagine this thing here as being the angle. This here is nothing more than an angle. So now when you secant the angle, it will be this divided by this. So the whole thing here is really this divided, the hypotenuse divided by the adjacent, which is root 1 plus 4x squared. So this whole, when you secant that angle, this whole thing here is nothing more than this. So you can put this into here, and then you got to so you put it into here. So imagine this as being 1 plus 4x squared to the power of a half, and then here you got to cube it. So now you get this times this. That will then give you this. That will then give you this. So if you tidy up the whole thing, it will give you this. Okay. Now use the same technique for all the others here. So the whole thing here will then become this, and then don't forget you're evaluating it from 0 to a. So now let me think. Sorry. Let me think. Yeah. So let me think. Well, somehow I got from here to here. Okay. You think about it. Hang on. Let me just move this across. Yeah. So we are now currently here, and then just tidy up, and then that will then give you this, and then tidy this up, and it will then give you this, and then tidy up, and it will then give you this. I can't follow what I did, so you've got to try and figure it out. Okay.